Now we'll start with another chapter of integration called as integration by quadratic. How do you identify quadratic? It will be in the form integral of dx upon quadratic. Right? Quadratic in the form that it will have the highest exponential as x square. It may or may not have the x term. See, quadratic, when you talk about quadratic is in the form ax square plus bx plus c. The highest degree of polynomial is 2. Now, if the highest degree of polynomial is 2, it is going to be quadratic. Your quadratic equation may or may not have the x term. Right? Suppose if it is a equation which cannot be solved, that means whose factors are not found, you cannot find its factors, in which case then you have to use the last term formula and find the factors. Let us try to illustrate this with the help of a couple of examples. So this is how you will see identify a quadratic, right? Let's see this. Integral of dx upon x square plus 5. Right? This can be written as integral of dx upon x square plus root 5 the whole square. 5 can be written as root 5 the whole square. This is in the form integral of x square, 1 upon x square plus a square. There is nothing but 1 upon a tan inverse of x by a plus c. Right? I'll do one thing to make things simpler. I'll write all the formulas on the right hand side of the board. So the formula that we use here is integral of 1 upon x square plus a square with respect to x is 1 upon a tan inverse of x by a plus c. Okay. Now let's see another sum, guys. Integral of dx upon square root of 16x square minus 9. One of the basic rules that you need to remember while doing quadratic is that the coefficient of x square should be 1. The coefficient of x square should be 1. Here, the coefficient of x square is not 1. You cannot solve quadratic integration unless and until the coefficient of x square is 1. So now, first thing I need to do is make this coefficient 1. How do I do that? By taking 16 common. If I take 16 common, this will become x square minus 9 upon 16. I have divided by 16, I have multiplied by 16. Right? Now, 16 can be taken common since it's a constant, it can be taken out. 1 upon root 16 is nothing but 1 upon 4. So that 16 when it comes outside, root 16 can be written as 4. This is integral of dx upon root of x square minus 3 upon 4 the whole square. I'll first write the formula so that you follow what I'm doing. Let's have a look at the formula. The formula that you will use is integral of 1 upon root of x square plus minus a square is log of x plus root of x square plus minus a square plus c. Fine? Now, in this case, if I use this formula, this will be 1 upon 4 log of x plus root of x square minus 3 upon 4 the whole square plus c, log mod. This can be written as 1 upon 4 log mod x plus root of x square minus 9 by 16 plus c. Let's see another sum, guys. Integral of dx upon root of 9 minus 16x square. Right? Basic rule, guys, that the coefficient of x square should be 1. To do that, I'm going to take 16 common. So this is square root of, I'm taking 16 common. If I take 16 common, this becomes 9 by 16 minus x square. Square root of 16 is 4, constant comes outside the integral sign. This is integral of dx upon square root of 3 upon 4 the whole square minus x square. Let us see the third formula that we are going to use in quadratic. Integral of 1 upon square root of a square minus x square is sine inverse of x by a plus c. Fine. If I use this formula, this will be 1 upon 4 sine inverse of x upon 3 by 4 plus c. So in that case, this will be 1 upon 4 sine inverse of 4x by 3 plus c. Fine, do we get this thing here? Let's see another sum, guys. Integral of dx upon 2x square plus 7x plus 13. Right? Now 13 2s are 26. There's no way you can get factors of this. And getting a perfect square is even more difficult. So what you have to do is convert this into a perfect square. How do I convert this into a perfect square? By finding out the last term. Simple. Guys, let's have a look at this. I can say that last term is middle term into middle term upon 4 times first term. That's the formula of last term that we have done. Some of us have even learnt this formula this way. Last term is half coefficient of middle term the whole square. Now let's see how we will use this formula. First, basic rule. Coefficient of x square cannot be equal to more than 1. It has to be equal to 1. So take 2 common. So this will be x square plus 7 by 2x plus 13 by 2. Constant 2 comes out. So 1 upon 2 integral of dx upon x square plus 7 upon 2x plus 13 upon 2. Find out the last term. Last term is middle term into middle term upon 4 times first term. So middle term 7 upon 2x into 7 upon 2x upon 4 times x square. So this is going to be 49 upon 16. Add and subtract 49 upon 16. So this will be 1 upon 2 integral of dx upon x square plus 7x upon 2 plus 49 upon 16 plus 13 upon 2 minus 49 upon 16. 1 upon 2 integral of dx. Since you have found out the last term, this becomes a perfect square. Since you have found out the last term, this becomes a perfect square. How do you find the factors of a perfect square? Square root of the first term, square root of the last term, and sine of the middle number. Square root of the first term, square root of the last term, and sine of the middle number. Plus, this can be written as, I could take 16 as the common denominator. So this is going to be equal to 104 minus 49. So this is going to be 1 upon 2 integral of dx upon x plus 7 upon 4 the whole square plus 55 upon 16. Now 55 upon 16 can be written as root 55 upon 4 the whole square. 104 minus 49 is 55, which I am writing as root 55 the whole square. Let us try to see the formula that we will use here. This is integral of 1 upon x. We've already written this formula, first formula. Integral of 1 upon x square plus a square, the first formula. Right? So 1 upon 2, this is 1 upon a tan inverse of x by a plus c. 1s are, 2s are. So this will be 2 upon root 55 tan inverse, take LCM. If I take LCM, this is going to be 4x plus 7 upon root 55. 4 and 4 common denominator will get cancelled, plus C. This is going to be your answer. Fine. Let's move on to the next one, guys. Integral of dx upon square root of 4x square minus 4x plus 3. Coefficient of x square has to be equal to 1. So dx upon square root of, I could take 4 common. So this will be x square minus x plus 3 upon 4. First thing what I've done is I've made the coefficient of x square 1. Square root of 4 comes out, becomes 1 upon 2. Integral of dx upon square root of x square minus x plus 3 upon 4. In order to convert this into a perfect square, I will have to find out the last term. Last term is middle term into middle term upon 4 times first term. So that's minus x into minus x upon 4 times x square, which is 1 upon 4. So I'm going to add and subtract 1 upon 4 dx upon square root of x square minus x, add 1 upon 4, subtract 1 upon 4. Right? Now this can be written as 1 upon 2 integral of dx upon, I just taught you how to find out the square root of a perfect square. How do you find the factor of a perfect square? Square root of the first term, square root of the last term, sine of the middle number. 3 by 4 minus 1 by 4 is 2 by 4, which can be written as 1 by 2. 3 minus 1 is 2. So 2 by 4 is nothing but 1 by 2. And 1 by 2 can be written as 1 upon root 2 the whole square. Right? I can use the second formula. Integral of square root of x square plus a square, log of mod of x plus square root of x square plus a square plus c. Right? This can be written as 1 upon 2 log mod x minus 1 by 2 plus square root of x minus 1 by 2 the whole square plus 1 by root 2 the whole square plus c. This can be written as 1 upon 2 log mod x minus 1 by 2 plus this. This whole thing has been derived from the original sum. This square root has been derived from the original sum. So this can be written as the original sum, that's 4x square minus 4x plus 3 plus c. That will be your answer. Right? Let's move on to the next one, guys. Integral of dx upon square root of 5 plus 4x minus x square. Right? Let's see how do we do this sum, guys. Now, coefficient of x square is 1. There are two rules that you need to remember while doing quadratic. A, the coefficient of x square should be 1 and it should be positive. The coefficient of x square should be positive. Two rules. Coefficient of x square should be 1, coefficient of x square should be positive. Here, coefficient of x square is negative. Since it is negative, first thing I'm going to do is convert it into positive. How do I do that? 5. Between these two terms, I'm going to take minus sign common. If I take minus sign common, I'll get x square minus 4x. Last term is missing. Let us find out the last term. Last term is middle term into middle term upon 4 times first term. This can be written as minus 4x into minus 4x upon 4 times x square, which is 1. So I is integral of dx upon square root of, now observe very carefully, 5 minus x square minus 4x. This was my original sum. I am going to add 1. When I add 1, since there is a minus sign common outside, that means in reality I am subtracting 1, right? So if I am going to be subtracting 1, there's a problem here, guys. This won't be 1, this will be 4, because x square cancels, 4 and 4 cancels, so 4 remains. So I'm going to add 4. Now if I'm adding 4 inside, in reality I'm subtracting 4. If I'm subtracting 4, to keep the equation constant, I'll have to add 4. So I've added 4, I have subtracted 4. This is going to give you integral of dx upon square root of 5 plus 4 is 9. 9 can be written as 3 square minus perfect square. Square root of the first term, square root of the last term, sine of the middle number. Integral of 1 upon square root of a square minus x square. The third formula, which is nothing but sine inverse of x by a plus c. Simple, straightforward sum, right? Let's move on to the next sum. I think I'll start from the beginning. Integral of dx upon square root of 5 minus 7x minus 2x square. Two rules, people, you have to remember. 1. The coefficient of x square should be 1. So let's make that as 1. How do I make that as 1? Very simple. All I have to do is take 2 common. If I take 2 common, this will become 5 upon 2 minus 7 upon 2x minus x square. So I make the coefficient 1. Second, the coefficient has to be positive. Now this 1 upon root 2, I am bringing it outside the integral sign. Dx upon, this is going to be square root of 5 upon 2. Between the second and the third term, I am taking minus sign common, so x square plus 7 upon 2x. Fine, do you get this thing here? Now, to make this as a perfect square, I will find out last term. Last term is middle term into middle term upon 4 times first term. Middle term 7 upon 2x into 7 upon 2x upon 4 times x square. That's 49 upon 16. This can be written as 1 upon root 2 integral of dx upon square root of, this is 5 upon 2, guys, let's see this, x square minus, no, plus 7 upon 2x. I'm adding 49 upon 16 inside the bracket. Since there is a minus sign outside, that means in reality I have subtracted 49 upon 16, so I'll have to add 49 upon 16. This can be written as 1 upon root 2 integral of dx upon 16, 40, 89. If I take 16 as the common denominator, that becomes 89, right? So it will become 89 upon 16. 89 upon 16 can be written as root 89 upon 4 the whole square. Fine. Minus perfect square. Square root of the first term, square root of the last term, sine of the middle number. There is a square root sign already present. Right? This is in the form integral of 1 upon a square minus x square. That's my third formula. 1 upon root 2. This is nothing but sine inverse of x plus 7 by 4 upon root 89 by 4 plus c. Let's simplify this. 1 by root 2. This is sine inverse of 4x plus 7 upon root 89, common 4, common denominator 4, and this 4 gets cancelled, plus c. So that will be your answer. Fine, do we get this thing clear? Next, let's move on to the next one, guys. Integral of dx upon 4 e raised to x plus 9 e raised to minus x. Whenever you have a negative indice, the first thing that you have to do is convert it into positive indice. So this can be written as integral of dx upon 4 e raised to x plus 9 upon e raised to x. I'm converting the negative indice to positive. Once you've done this, take LCM. So if I take LCM, this will be 4 e raised to x the whole square plus 9 divided by e raised to x. I will have a common denominator, e raised to x. Denominator of denominator becomes numerator, so I can take that e raised to x common in the numerator, right? Let us assume that e raised to x is t. Differentiate with respect to x. D by dx of e raised to x is e raised to x is dt by dx. Therefore, you can say that dx is dt upon e raised to x, right? Now, I could say that I is integral of e raised to x upon 4 e raised to x in the denominator. I am substituting as t, so 4t square plus 9 dx can be written as dt upon e raised to x. E raised to x in the numerator and denominator cancels, quadratic, basic rules. Coefficient of x square term should be 1, coefficient of the quadratic square term should be 1. So 1 upon 4 common, dt upon t square plus 9 upon 4. 9 upon 4 can be written as 3 upon 2 the whole square. Integral of 1 upon x square plus a square, first formula, 1 upon a tan inverse of x by a plus c. Ones are, twos are, answer is 1 upon 6 tan inverse, we substitute the value of t. So that's e raised to x. Denominator of denominator becomes numerator plus c. That will be your answer. Fine, do we get this clear? Let's move on to the next one, guys. Integral of cos x upon square root of sin square x minus 2 sin x minus 3 dx. Right? Let us assume that sin x is equal to t. Differentiate with respect to x. So d by dx of sin x is cos x. Cos x is nothing but dt by dx. Therefore, you could say that dx is equal to dt upon cos x. Fine, do we get this thing clear? I can say I is integral of cos x upon square root of, I'm substituting the value of sin x, guys. So this is sin square x, so this will be t square minus 2t minus 3 dx is nothing but dt upon cos x. Cos x in the numerator, denominator gets cancelled. Make this as a perfect square. How do I make this as a perfect square? Last term is middle term into middle term upon 4 times first term, which is nothing but minus 2t into minus 2t upon 4 times t square, which is 1. This can be written as integral of dt upon square root of, this is t square minus 2t plus 1 minus 3 minus 1. I added 1, I subtracted 1. Right? Now this can be written as, since this is a perfect square, this can be written as t minus 1 the whole square. square root of the first term, square root of the last term, sine of the middle number. Minus 4. Minus 4 can be written as minus 2 the whole square. So now this is in the form integral of 1 upon square root of x square plus, minus a square, second formula. So this will be nothing but log mod x plus square root of x square minus a square plus c. We substitute log mod t can be written as sin x. So sin x minus 1 plus square root of, this can be written as sin square x minus 2 sin x plus minus 3. Remember this I got from the original sum, so I am writing the original sum back, plus c. Pretty simple. Let's move on to the next one, guys. Integral of sec square x upon 5 tan square x minus 12 tan x plus 14 dx. Again, very similar to the previous sum. Let tan x be equal to t. Differentiate with respect to x. dy dx of tan x is sec square x. Sec square x is dt by dx. Therefore, you can say dx is dt upon sec square x. I is integral of sec square x upon 5t square minus 12t plus 14. Dx can be written as dt upon sec square x. Now, this can be written as integral of coefficient of x square should be 1. 1 upon 5, I am taking constant outside, guys. Can be written as dt upon t square minus 12 upon 5t plus 14 upon 5. Right? Make this as a perfect square. How do I make this as a perfect square? Last term is middle term into middle term upon 4 times first term. This can be written as minus 12t upon 5 into minus 12t upon 5 upon 4 times t square. Cancels. 4 1s are, 4 3s are. That's 36 upon 25. So this is going to be 1 upon 5 integral of dt upon t square minus 12t upon 5 plus 36 upon 25 plus 14 upon 5 minus 36 upon 25. I am adding 36 upon 25, I am subtracting 36 upon 25. This is 1 upon 5 integral of dt upon perfect square, square root of the first term, square root of the last term, sine of the middle number. 14 5s are 17. So when you subtract this, this is going to give you 34. This will give you 34 upon 25, which can be written as square root of 34 upon 5 the whole square. 1 upon 5. Integral of 1 upon x square plus a square, 1 upon a tan inverse of x by a plus c. 5 and 5 gets cancelled, so you will get 1 upon root 34 tan inverse. This is going to be LCM 5. T can be written as tan x minus 6 upon root 34 plus c. That will be your answer. Right? Let's move on to the next one, guys. x upon 2 plus 3 sine square x. Now guys, try to understand something. If, let's see this, if a sum is of the order 1 upon a plus b sine square x, or integral of 1 upon a plus b cos square x, or integral of 1 upon a plus b sine square x plus c cos square x, if the sum is of this type, the easiest way to solve this sum is divide numerator denominator by cos square x. Divide numerator denominator by cos square x. Right? So if you have a quadratic in any one of this format, the method to solve this is divide numerator and denominator by cos square x. Right? Let's see a sum based on this type, guys. We've already written the sum. So you have this. I told you the method to solve this is divide numerator and denominator by cos square x. So I can say I is integral of, I'm dividing the numerator by cos square x, 2 upon cos square x plus 3 sine square x upon cos square x dx. I have divided the numerator and denominator by cos square x. Integral of 1 upon cos is sec square x. This is 2 sec square x plus 3 tan square x dx. Identities. Sec square theta is nothing but 1 plus tan square theta. So this is sec square x to 1 plus tan square x plus 3 tan square x dx. I substituted sec square theta, integral of sec square x upon 2 plus, open the bracket, 2 tan square x plus 3 tan square x dx. Let us assume that tan x is equal to t. Differentiate with respect to x. If I differentiate with respect to x, d by dx of tan x is sec square x, is nothing but dt by dx. Therefore, you can say that dx is dt upon sec square x. Right? Now, let's continue with the sum. I could therefore say that I is integral of sec square x 2 plus 2t square plus 3t square dx can be written as dt upon sec square x. Some of you would want to ask me a question as, sir, why didn't you add this 2 tan square x and 3 tan square x here? Yes, you can add it. You could have written 5 tan square x. I just wanted to do that in the next step. So you can do it there if you want. So sec square x gets cancelled. Integral of dt upon 5t square plus 2. Coefficient of x square should be 1, 5 gone out. Dt upon t square plus 2 upon 5. 2 upon 5 can be written as root 2 upon root 5 the whole square. This is in the form integral of 1 upon x square plus a square, which is nothing but 1 upon a tan inverse of x by a plus c. Right? That's my first formula. Root 5 and 5 gets cancelled to give you root 5. So this is 1 upon root 10 tan inverse of t. T can be substituted as tan x. So this is going to be root 5 tan x. Denominator of denominator becomes numerator upon root 2 plus c. That will be your answer. Right? Next, let's move on to the next sum, guys. Integral of dx upon 2 minus 3 cos square x. Right? I just gave you this method that when you have the sum in the order integral of 1 upon a plus b cos square x, you divide the numerator and denominator by cos square x. Divide numerator and denominator by cos square x. So I'll get I is integral of 1 upon cos square x upon 2 upon cos square x plus minus 3 cos square x upon cos square x dx. This is integral of 1 upon cos is sec square x upon 2 sec square x minus 3 dx. Use identity in the denominator, sec square x. Sec square theta is nothing but 1 plus tan square theta, 1 plus tan square x minus 3 dx. Integral of sec square x 2 plus 2 tan square x minus 3 dx. Now let us assume that tan x is equal to t. Differentiate with respect to x. dy dx of tan x is sec square x, which is equal to dt by dx. Therefore you could say that dx is dt upon sec square x. So I could say that I is integral of sec square x upon 2 plus 2t square. I'm substituting tan square x as t minus 3 dx can be written as dt upon sec square x. Sec square x gets cancelled. This is integral of dt upon 2t square minus 1 plus 2 minus 3 is minus 1. Coefficient of x square should be 1. So 1 upon 2 integral of dt upon t square minus 1 upon 2 can be written as minus 1 upon root 2 the whole square. Now this makes the sum very interesting. I could use the formula here. Integral of 1 upon x square minus a square is 1 upon 2a log mod x minus a upon x plus a plus c. Let's see this once again. Integral of 1 upon x square minus a square is 1 upon 2a log mod x minus a upon x plus a plus c. Okay, so if I use that formula here, this is 1 upon 2, 1 upon 2a log mod x minus a upon x plus a plus c, right? Root 2 and 2 is cancelled to give you root 2, so your answer is 1 upon 2 root 2 log LCM in the numerator, root 2 goes up, t we have written as tan x, so this is going to be root 2 tan x minus 1 upon root 2, we will not write that for the time being, I will tell you why, upon root 2 tan x plus 1. The common denominator of root 2 in the numerator and denominator will cancel, plus c. That will be your answer. Fine. Let's move on to the next sum, guys. The last sum to finish this chapter. Integral of dx upon sine square x plus 2 cos square x plus 3. Look at this, guys. I had already informed you that if the sum is of the order integral of 1 upon a sine a upon 1 upon a plus b sine square x plus c cos square x, you have to divide the numerator and denominator by cos square x. So let's see this, people. Divide numerator and denominator by cos square x. So I'll get I is integral of 1 upon cos square x upon sin square x upon cos square x plus 2 cos square x upon cos square x plus 3 upon cos square x dx. This can be written as integral of sec square x upon tan square x plus 2 minus 3 sec square x dx. This can be written as integral of sec square x upon tan square x plus 2 minus 3 identities. Sec square theta is 1 plus tan square theta dx. Integral of sec square x upon tan square x plus 2 minus 3 tan square x dx. Let tan x equal to t. Differentiate with respect to x. dy dx of tan x is sec square x is dt by dx. Therefore, you could say that dx is dt upon sec square x. So I can say I is integral of sec square x upon t square plus 2 minus 3 t square dx is dt upon sec square x, right? So sec square x gets cancelled, so integral of guys, can you just look up here? This was plus, so this will also be plus, so this will be plus, it's going to be plus all throughout, plus 3 tan square x. Now, this is nothing but 1 upon 4 t square plus 5 dt. I could take 1 upon 4 common, so this is 1 upon t square plus 5 upon 4 is nothing but root 5 upon 2 the whole square dt. Remember, I told you that the coefficient of x square should be 1. This is 1 upon 4 integral of 1 upon x square plus a square is 1 upon a tan inverse of x by a. First formula, people. So this is going to be 1 upon a tan inverse of x by a plus c. So this is 1 upon 2 root 5 tan inverse of 2t upon root 5 plus c. We substitute the value, so this is 1 upon 2 root 5 tan inverse of 2t. T can be written as tan x upon root 5 plus c. This finishes this chapter. Right? Let's stop here for the day. We'll continue with this in the next lecture. Thank you.